Dear students, during this lecture you will try to understand the Newton's first law of motion and the term inertia. As discussed earlier, we know that the Galileo, an eminent scientist, concluded that if net external force is zero, a body at rest continues to be at rest and a body in uniform motion continues to move uniformly along the same straight line. So Newton modified this law and he stated that a body at rest will remain at rest and a body in motion will remain in uniform motion unless acted upon by an unbalanced force. It means this is called Newton's first law of motion. It means a body on its own does not change its position. An external force is required to change its state of rest or its state of motion. So this unwillingness of a body to change its state of rest or uniform motion is known as inertia. Try to understand now with help. Suppose if equal forces are applied on two bodies, the acceleration of the body will be different. So in this case, the body having the acceleration is F upon m, means lesser the body, the lesser the mass, the more is the inertia. It means the property of a body to allow a smaller acceleration is called inertia. In other words, we can say that the inertia is directly proportional to mass. Now come to the types of the inertia. It means the Newton's first law of motion defines force as well as inertia. There are two types of inertia, the inertia of rest and inertia of motion. The definition is very simple. You can simply add the body at rest will remain at rest unless acted upon by an unbalanced force. This is for inertia of rest. And we can write here a body in motion will remain in uniform motion unless acted upon by an unbalanced force. This is the definition of inertia of motion. Try to understand with the help of an example. When a bus suddenly starts moving forward, the passengers fall backward because the lower part of the body of passenger in the bus is in contact with the floor of the bus that comes into motion along with bus, but the upper part of the body remains at rest due to inertia of rest. On the another example, when a carpet is beaten with a stick, then fibers of the carpet comes into motion and hence moves forward, whereas the dust particles remain at rest due to inertia of rest and fall down. The inertia of motion, when a moving bus suddenly stops, the passengers fall forward. The reason is very simple. In this case, the lower part of the passenger body comes to rest, but the upper part of the body continues to remain in motion due to inertia of motion. The another example, a person jumping from a speeding train or bus may fall forward because the feet of person comes to rest on touching with ground, but the upper part remains in motion due to inertia of motion. Hence, the person falls forward. Now, you can understand the example, Newton's first law of motion with one example. Refer to the figure. Now, in this the card and coin experiment, we take a smooth card, say a plastic card, and keep it on a glass. Place a coin on the card and flick the card sharply in the horizontal direction. The card flies away and the coin drops into the glass. What happens? Initially, there are two forces acting on the coin. Earth pulls the coil downward, that is weight, and the card pushes it upward, that is reactionary force. These two forces balances each other and the coin remains at rest. So when we apply a horizontal force on the card, it is accelerated and it moves away. But so there is no force on the coin in the horizontal direction. It remains in its original position due to inertia of rest. But when the card moves away from underneath the coin, the normal force on the coin becomes zero. The weight is the only force on the coin and hence it accelerates downward to fall into the glass. So what we concluded, we simply concluded that the Newton's first law of motion defines force as well as inertia. Thank you and have a